Welcome to Module 14 of Engineering Vibrations 1 and Introduction to Single Degree of Freedom Systems. Today's learning outcome is to now solve for the transient response solution to the differential equation of motion for a simple single degree of freedom system. And so we're down here. We've got the mathematical model of our system, and we're looking for the solution, the transient, or what's called the free solution to the system. It has no forces attached to it or being applied to it. And so here's where we had left off. We have our differential equation of motion, and we came up with the general solution. Last class, we defined the natural frequency, and so we have the natural frequency goes in here and here to replace the symbols square root of k over m, and so I end up with this response. And the question becomes, how do you solve for B1 and B2? And so I'd like you to stop the video, think on your own, and try to come up with how would we solve for B1 and B2, those unknown constants. And what you should say is we're going to have to apply initial conditions to the system. And so let me give you some initial conditions. Let's say that for time 0, we give the system an initial displacement and an initial velocity. And Q, remember, is measured from the static equilibrium position here. And so we're going to give it some initial displacement from that position and some initial velocity. Let's now apply those initial conditions to our system. And so first of all, let's apply the initial displacement. So for Q at time 0 here, this becomes 0, time is 0 here, so we have Q sub 0, the initial displacement, is equal to B1 cosine of 0 plus B2 sine of 0. And cosine of 0 is equal to 1, and sine of 0 is equal to 0. So we end up with Q0 equals B1, so we solve for the unknown constant B1. Now we're going to take the derivative of Q dot and enter time 0. So the derivative of Q dot, the derivative of cosine is minus sine, and so we have minus B1 sine, and we also bring the argument out, square root of k over m, which is also omega natural, and it's at time 0. Same thing over here for the second term. We have B2, the derivative of sine is cosine, and the argument comes out square root of k over m, or omega natural. And then that's going to be cosine, and time is equal to 0, so there's 0. And so sine 0 again is equal to 0. Cosine of 0 is equal to 1. And so we get B2, the second constant, is equal to the Q dot sub 0 divided by the omega natural. And now we have those two unknown constants. And so our response solution becomes as shown here. And so we've solved for the free vibrations undamped, the response solution Q in terms of in time. And so we'll continue on after this with looking further at that solution. See you next time.